Alright folks, so today we're going to be checking out this problem from the 2010 AMC 10A. AMC, learn with me! Alright folks, so let's check out the 7th problem from the 2010 AMC 10A. Alright, let's check it out. By the way, I haven't seen this one before, so we're going to be doing it real time. Okay, so let's read it. We have Crystal has a running course marked out for her daily run. She starts this run by heading due north for 1 mile. Okay, so she goes north for a mile. She then runs northeast for a mile. Okay, she runs northeast for a mile, then southeast for 1 mile. And the last portion of her run takes her on a straight line back to where she started. Okay, so we got her back on a straight line to where she started. How far in miles is this last portion of her run? All right, so let's see if we can understand what's happening. So Crystal has a running course. She starts by heading due north for a mile. So here, this is 1 mile. And then what happens? She heads northeast for a mile. So if you don't know your directions, it's good to list them out now. Never eat soggy waffles. So northeast would be in this direction, right? So after she goes 1 mile north, what she's going to do is go a mile northeast. So what's that going to look like? That's going to be something like this in a 45-degree angle to my horizontal. Okay, and then she goes southeast for a mile. Southeast is this way. So she's going to go southeast for a mile. Again, this right here would be 45 degrees. Okay, and then what? So this is 1 and this is 1. And this, I should make this an arrow actually. Okay, and then what happens? We did her north part. She went northeast, we did that. She went southeast, we did that. And then it says the last portion of her run takes her on a straight line back to where she started. So we want to find this distance, this straight line distance back to where she started. How can we find that? Okay, well, I'm not sure actually. But it looks like it's going to be a bunch of triangles, right? So most notably, this distance right here looks like the hypotenuse of this right triangle. That's pretty interesting. This right triangle has a leg of side length 1. And what about its other leg? How long is this leg of my right triangle? Well, let's see. If this is 45, and this, what is this? Well, I'm not quite sure what that has to be, but this is 45 and this is 1, so this also has to be 45. So it's an isosceles triangle. So this has to be 90 degrees. So it's a right isosceles triangle. Okay, so if this is 1 and this is 1 and it's a right triangle, then this side must be square root of 2. But if that side is square root of 2 and this is also a right triangle, then what is my green length? Well, I can just use the Pythagorean theorem, right? Let's call this C. So I have my 1 squared plus my square root of 2 squared is equal to C squared. And so if I simplify this, I'll get 1 plus 2 is equal to C squared. C is equal to square root of 3. That means our answer is choice C. And so that's it, folks, for question number 7 of the AMC 10A 2010. If you have any other questions, leave them in the comments below. We'll check you out next time.
Embedded plus MKO plus scaffolding equal learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.